Before we talk about the React Virtual DOM, let's refresh on the concept of the browser DOM. DOM is short for Document Object Model. I've mentioned before that the Elements tab in the Developer Tools window gives us a representation of the DOM in real time. But the DOM is not HTML, nor is it JavaScript. It acts as an interface between the two. The DOM is an API, an application programming interface. It's a set of specifications on how programming languages and HTML can interact with each other. It maps HTML elements to a node-based, tree-like representation of HTML behind the scenes, an interface that programming languages can easily understand, traverse, and modify. You see here an example of some HTML and its corresponding representation in the DOM. This representation is created by the browser using a technology called a browser engine. Every time a web page is loaded, your browser creates this abstract model and holds it in memory. The DOM is the interface that makes it possible for you to refer to HTML elements and attributes using JavaScript object and property syntax. So you might create a new image element node in JavaScript like this. Then you could insert this node into the DOM using a method like appendChild, and it would finally be rendered by the browser into this HTML element. To repeat, there is an interface between a programming language like JavaScript and the actual code that gets rendered in the browser with HTML and CSS, and the DOM is that interface. It is cross-platform and language independent, so it can be used in all operating systems. And you can interact with it using other languages, not just JavaScript, though the vast majority of the time it will be JavaScript. Whenever you cause any changes to a web page's view with JavaScript, then the affected nodes and their children in the browser DOM are recreated. Along with that, the browser view is also re-rendered graphically, and that can be an expensive process. Now we can talk about the virtual DOM and why it exists. The virtual DOM is a technique not unique to React. React is one implementation of it. The React application maintains a lightweight representation of the browser DOM that it keeps in memory. It's much faster and easier to update the virtual DOM because it doesn't require re-rendering the browser view every time you do it. With React, any changes to the DOM are first made in the virtual DOM. So if a user clicks on a button and it changes the color of the web page's background, for example, instead of manipulating the real browser DOM directly, this change first gets made in React's virtual DOM. When changes are made to the virtual DOM, React compares the changes during a process called reconciliation, which is done through its reconciliation engine named Fiber. In this process, it looks for which nodes have changed in the DOM tree. Then it figures out the most optimized way to patch the browser DOM with the changes and to minimize the amount of re-rendering while applying the changes. For example, by sending multiple changes in a combined batch instead of one at a time. This is the main reason why you need to use setState for any state changes in React instead of setting the state directly with an assignment operator. setState sends your change through the virtual DOM, so if you don't use it, then you're sidestepping one of the most useful features of React. You also learned before about setting unique key attributes when rendering lists of React elements using map before. When doing so, you are helping out the React reconciliation process by giving it stable markers to track and look for when changes have been made, so that it doesn't re-render unchanged items unnecessarily. Hopefully this has made it a little more clear for you what the virtual DOM is and why React uses it, and why it's important to use setState and keys. It helps React do its job, making updates to your web app in an optimized way.